Welcome back to the morning show. It's Wednesday. That means it's time for a science lesson with the wise guy.
And today we had to take the experiment out of the studio and into the lab, and that's where Matt Sullen is live this morning. Good morning, Matt. So talking high voltage electricity this morning.
That's right, Matt. Hi, Robert. How are you?
Good. How are you?
I'm wearing my high voltage shirt. Can you see?
It's certainly a can't miss it.
So in the last little segment, we saw that if you want to change a regular voltage like 120 volts up to some arbitrarily high voltage, all you have to do is use a transformer. And a transformer is just some loops of wire that you put around an iron core, and you can basically step the voltage up to be as high as you want or back down again to be low again by just building this very simple device. And so now let's see why we might want to do that. If you look behind me here, I have this enormous demonstration. It's one of our biggest ones. And over to my left, to your right, we have the power station. So over there we have a source of 110 volts. Then we're going to put the power up on these transmission lines or these wires. These are supposed to represent the things that you see going across the countryside. And over here is your house. So we have the power going from the power station over there over to your house over on this side.
Okay.
And we're going to try to send the power using low voltage AC, like 110 volts, and we'll see it doesn't work that good. And then we're going to step it up to a high voltage using a transformer, and we're going to see that it works much, much better. So that's sort of the plan of attack here. So let's go over to the power station. And I'm just going to turn on this little switch, and you see the light come on. That just means that the power station is operating now. This is the Clinton power station, let's say. And what I'm going to do is throw these switches, so I'm transferring the power directly from this side, which is just the line voltage, up to these wires that run up above my head. So that's what I've done right now. So right now on these wires, there's 110 volts AC, the same thing that comes out of the wall socket. And then I'm just going to attach those to the light bulbs over here. So this is your house. And you see that the light bulb over on this side, the one I'm pointing to, is a lot dimmer than the one over there was. And what's even worse, if I hook up two light bulbs by just closing the switch, so now we turn on the lights in two rooms, let's say, it's very, very dim. So this doesn't work real good. We have a lot of voltage over there, but by the time we get over here, we haven't managed to get much power over to this side. The reason for that is actually very simple to understand. It's because the power that you get out of an electrical system is the product of the current and the voltage. So you need to have the product of the current and voltage to be big. Now, if you have a lower voltage, like only 110 going across these wires, that means you have to have a relatively high current. But these wires are very, very skinny, and so they don't transmit current that efficiently. They have a large resistance, and so by the time we get over there, we've lost most of the power just heating up these wires. There's very little left over there. So now what we can do over here is we can hook up a transformer, which is at the bottom, just by putting these switches the other way. So now we transform these up to 575 volts instead of 110 volts. And so now we're sending 575, almost 600 volts across on these wires. Now over on this side, we don't want to put 575 volts onto our house because we might ruin something. So we have a transformer hooked up backwards. So we take the 575 and we put it back down to 110, and now we see how bright this light bulb is. It's just as bright as the one over on that side. Because we have a much higher voltage, we're transmitting much less current than we did before. That means that we don't waste as much power in these power lines. And in fact, I can hook up both of these light bulbs, and they're both very bright now.
Yeah.
Okay.
What about, hey, Matt, does a circuit breaker play any role in something like this?
Very little role. So anyways, I asked about this last time, and of course, Will Gibbons, this wonderful friend of mine, sent in the right answer. He knew that the reason you want to step up the voltage high was because of losses in the transmission lines. And just before we finish here, let me ask you this following question for next time. You often see birds sitting on these high voltage power lines. You have high voltage power lines going all over the country, very, very high voltages, yet the birds just sit there quite happily and they don't get electrocuted. Can somebody explain to me why that is?
Okay.
And then we'll talk about that next week.
All right. And are you going to have the squirrel answer too?
Oh, the squirrel answer. Well, squirrels are not as fortunate as birds because, well, yes, I'll have the squirrel answer next week. I don't want to give it away now.
Don't give it away yet. I think they're connected. Okay. Matt Sullen live in the lab. Thanks for that.
Physics or biology?
A little bit of both, apparently.